Alright, class, we're going to start chapter 3 and pretty good, classic, solid, probably difficult Algebra 2 topic. Absolute value equations, maybe a little bit more Algebra 1. Absolute value inequalities, definitely Algebra 2. And since we didn't hit the absolute value equations very hard yet, there's a lot to learn in this section. We're going to start off with something that is a bit more review. And that's just, simply solve 2x plus 1 equals 9. It isn't actually a review. It's just kind of lead you into going, well, look how it's similar here, look how it's similar here, and then hopefully you got your thinking caps on because we need some real logic for this one. So we're just going to, for all of these, every single one of them, we're going to subtract 1 from both sides, and then we will divide by 2. So we're going to have 2x equals 8, divide by 2, and we're going to get x equals 4. We do that for the one below. Let's take care of that one before we go to the right and deal with the absolute values. When we deal with this one, the only thing you have to do is remember there is one rule that's different for solving an inequality than for solving an equation. And recap, an equation has this sign. An inequality has a variety of signs. It could be greater than or equal to, greater than, less than or equal to, less than. Those are typically the 4 inequalities we're going to see when we're solving. There are other inequality signs that you could see, such as not equal to or approximately equal to. We just don't typically see those when solving. Okay, so when we multiply or divide by a negative, this sign will flip. That's not going to happen here. I'm going to subtract 1. I'm not multiplying or dividing by a negative, I'm subtracting. 2x is less than or equal to positive 8. Divide by 2. All the same steps we had in that last equation, only we have an inequality and it doesn't flip. So x is less than or equal to 4, and that would have a solid point at 4, and it would be less than, so it would be everything to the left. So there's a quick sketch of a graph of x is less than or equal to 4. Okay, an absolute value equation. We are going to first isolate the absolute value. So we're going to do exactly the same steps as we did in these two. So we're going to subtract 1 from both sides and divide by 2. We're going to get, oh look, didn't notice that that was a plus sign. Maybe you did. That should have been an equal sign the whole time. So let me fix that. So I'm just going to skip to it. That 9 is going to become a 4 because I'm going to subtract 1 from both sides and divide by 2. So I will get the absolute value of x plus 5 is equal to 4. Again, same steps. That was a 9. I'll be subtracting 1 from both sides. It'll become an 8. I'll divide by 2. It'll become a 4. So I'm just taking this to where I've already done the same type of problem 2 times in a row. So I've got this thing. Now you see it's an x plus 5, but perhaps it would be better if you didn't see that. Perhaps it'd be better if you said, hey, I have something inside this absolute value, and when it comes out, it's going to be a 4. The absolute value of a number is the distance of that number from 0 on the number line. So if it's negative 2, that's 2 away from 0 on the number line. In general, when something comes out of the absolute value, it's going to be positive. So this thing that comes out will always be 4, but what could it have been before it came out? Well, the absolute value of 4 is 4, which means that question mark could have been a 4, or the absolute value of negative 4 also could have been a 4. So you have to realize that this thing that was the question mark, it could have been 4 or it could have been negative 4. And now, that thing that was the question mark was the x plus 5. So you say x plus 5 is either 4 or x plus 5 is equal to negative 4. So two equations to solve. Subtract 5 from both sides. and we get x equals -1. And over here, subtract 5 from both sides, and we get x equals -9. And, you know, this is some deep logic, perhaps, for some of you. You ought to go check it. -1 plus 5 is 4. The absolute value of 4 is 4. 2 times 4 is 8, plus 1 is 9. The -1 works. So now you check -9. -9 plus 5 is -4, and the absolute value of -4 is 4. Multiply by 2, it's 8. Add 1, it's 9. So these both check out. Alright, this is a lot of work so far for this one page. Now it gets even more complicated. We've got this absolute value inequality to solve. Okay, same sort of steps, except for after I subtract 1 and divide by 2, I'll have x plus 5. The absolute value of x plus 5 is less than or equal to 9. Not 9. It'll be the absolute value of x plus 5 is less than or equal to 4. That same 4 we've been dealing with for the last 3 problems. So we'll have the absolute value of x plus 5 is less than or equal to 4. Just like it was in all these problems, simply because each time it's 9 minus 1 divided by 2. Okay, so what numbers? Okay, I'm going to go back to having a question mark here. If I don't know that that's an x plus 5, just know there's something inside the absolute value, and it is less than or equal to 4, think of all the things that that could be. It could be 4, or 3, or 2, or 1, or 0. Don't worry, I'm almost done. -1, -2, -3, -4, but not -5. Why not -5? Because the absolute value of -5 is 5, and 5 is greater than or equal to 4. So there's this stopping point for what this number can be. It's an inequality, but it doesn't just get bounded in one direction. So this thing right here could be anything, any number between -4 and 4. So that thing, that question mark, could have been anything between -4 and 4. But that question mark was an x plus 5. So let's pick it up from there. The x plus 5 could be less than or equal to 4. And it can also be x plus 5 is greater than or equal to -4. It has to be between -4 and 4, which means it has to be larger than -4. See, larger than -4, and it has to be less than 4. And there's our less than 4. Solve each of these individually, subtract 5 from both sides, and I will get from this one, x has to be less than or equal to -1. And from this one, I'll subtract 5 from both sides, and I will get x is greater than or equal to -9. So it's these two combined. X has to be greater than or equal to -9 and less than or equal to -1. So between -9 and -1. So solid point, bounded at -1 and -9. Now this stuff should look pretty familiar. We've done these before. They are compound inequalities. So here's a couple of compound inequalities that we are going to solve. Their absolute value. Flash forward. This is going to turn out to be an and. This one is going to turn out to be an or. And you've got to be able to figure that out. And again, flash forward. How are you going to do that? You have to remember from previous work that this graph that has opposing rays, this is an or. But this one that is this barbell shape, this is an and. let's actually just take care of these while we're here. So this would be x is less than or equal to negative 10. This scale skips. Negative 4, space, negative 8. So each one of these tick marks is 2. So x is less than or equal to negative 10. On this side, x is greater than, but not greater than or equal to, because it's the open dot, greater than 14. Now over here, it is a between, but it's also an and. This would be x is less than 6. Actually, less than or equal to 6, because it's solid. Each of these tick marks is 1. And over here, x is bigger than negative 7. The non-inclusive, because it's an open dot. Okay, now let's go back and tackle these much more difficult questions. Step 1 is going to be to isolate the absolute value. On the first page, the one we spent forever on, this one right here, when we were isolating that, we had basically just fast forwarded because we had isolated, or we had basically subtracted 1 and divided by 2 so many times that I just jumped forward. So full out, multiply by 2 on both sides. It'll become the absolute value of x minus 3 is less than 8, because I multiplied by 2 to both sides. This 2 cancels out that 2, and then we balance out the equation. It comes over here, so that's an 8. So we now have, with one step done, isolated the absolute value. So this something is less than 8. Now this is very much like the problem on this page, because it also was the absolute value is less than. When that happens, you get an and. If you can't remember that, and most students can't, you just think of different examples that work and some that don't, and you'll figure it out. For instance, if you think, hey, can this thing be 9? No, it can't, because 9's not less than 8. So you'll figure out that it will be a between, not an or. Okay, so x minus 3 has to be less than 8. And x minus 3 has to be larger than negative 8. Because again, think of all the things it could be. It could be, well, not 8, because it's a non-inclusive boundary, but it could be 7 or 7.5 as well. It could be 7 or 6 or 5 or 0 or negative 5 or negative 6, because the absolute value of negative 6 is 6, and that is less than 8. It can go all the way down to negative 8, but it can't be any less than that. It has to be bigger than that negative 8. Okay, so you have your two inequalities set up. Now solve them. Add 3 to both sides. This one gives you x is less than 11. Add 3 to both sides. This one gives you, add 3 to both sides, x is greater than negative 5. Negative 8 plus 3 is negative 5. So our ultimate answer is x is less than 11. I know that looks like a k, but it's an x. X is less than 11, and x is greater than negative 5. And the graph of that, open, negative 5. It's an and, it's the barbell, it's 11.